Good morning. We are moving on to indicator 5. So I hope your test went well yesterday. I will be grading those today. And then once the virtual kits get those made up, I think they're all coming in today. And so we will be able to go over those in class probably on Friday. Friday is a short lesson. So for indicator 5, this is where we begin the graphing portion of Algebra 1. So today is the very first day. The first thing we're going to talk about is slope. And then the second thing we're going to talk about on the graph are intercepts. So we're going to do a little bit of both. We're actually going to start with slope. And whenever we're talking about slope, this is a definition you definitely need to write. This is actually what we refer to as the steepness of a graph. And the slope determines how much a graph is slanted. And we always measure this. Sometimes you'll hear rise over run. Sometimes you see these symbols, delta X over delta Y. Those triangles are a Greek letter. So that delta means change. So you'll hear change in X over change, or change in Y over change in X. I have lost my mind, kids. Switch that. Change in Y over change in X. Y is always the rise. And then the formula, and actually, another thing that you'll hear for slope, we never use S for slope. We use the variable M. Now, I want you guys to know, if you can tell me why this is M, I'll give the first person that can tell me by email or in class why we use M for slope and instead of the letter S, I will be throwing out some bonus points. So do some research today, a little extra assignment. Now, we are actually going to do slopes by counting on a graph today and by the slope formula. So we're actually going to move on and do slopes by graphing first. All right, so we will be moving on, and I probably should have just had a coordinate graph to paste on here, but I'm just going to go 5 each way. You guys can do the same thing. And if you guys need some time to make your graphs, always remember you can pause. So I'm going to create 2 points. I'm going to create a point here at -2, -1, and I'm going to create another point at 0, 3. And if I draw a line between these 2 points, not a line segment, a line, I'm actually going through the entire graph. If I want to count the slope, I'm going to count the rise first and then the run. Now, whenever we talk about rise, we always go from, I always count left to right. We count like we're reading a book. So we will actually be starting over here at -2, -1. We want to figure out how many units do I go up. So for this area, how many units did I go up? I went up 1, 2, 3, 4 units. And since I went up, that is a positive direction. So that is a +4. And then to go over to this point, I went over 1, 2. And the right is a +2, because positive on the number line goes to the right. And so 2 negatives would then make this a +2. So the slope here is a whole number, +2. Now on slope, we will be reducing fractions. I know in solving equations, I didn't require you to, but on slope, we will. It makes it easier to graph with smaller numbers, so we will be reducing. So let's try another example. Same thing, let's make a graph. Let's try to stick with like 5 by 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, my next slope, I'm going to go to -1, 0. And then I'm going to make another point at 4, -1. And I'm going to draw my line through. And you'll have to forgive me, my lines aren't as straight as what they could be. So on this one, we're again going left to right. So we're going to start right here at -1, 0. And so in order to go from that point to the left over to the other point on the right-hand side, we have to go down. Now, how many units? That's only down 1. So we went down, so that's why I chose a negative direction. So the rise is -1. I went down 1. Now, how many units do I go over to get to this point? I start from where I turned. I went 1, 2, 3, 4, 5 units. Right is positive. So a negative divided by a positive would give me a negative, and that is a fraction 1/5. So we had the last example, it was going uphill, so that's why it was a positive slope. The second example that we did goes downhill from left to right, so that's why it's a negative slope. So in slope, you can actually have 4 different, if it's going uphill, your slope is always positive. If it goes downhill, it's always negative. Now, if you have a flat line, a horizontal line that goes straight across, that is actually what we call a 0 slope. And you can actually use the number 0 as well. And then if it is a vertical line, that means it's a rise, but the run is 0, and you can't divide by 0, so we call this undefined. So if you have a horizontal line, so a horizontal line right here gives us a 0 slope. A vertical line gives you a slope. We actually say the word undefined. So we never leave it as like 7/0. We actually write the word undefined. So you guys will have some practice counting slope. If you have other questions about counting slope, feel free to email me. But I'm actually going to move on to the slope formula. So if you are just given 2 points, so you are given coordinates, and so you have an x and a y for the first coordinate. That's why I put those subscript 1s. And then you have a second ordered pair for the second point. Hopefully you guys did this formula in middle school. y2 minus y1 over x2 minus x1. So you're going to subtract the 2 y coordinates for the top, and then for the denominator, you're going to subtract the x coordinates. So we got to remember to pay attention to our rules. Like if we're subtracting a negative, that turns into addition. So we'll do some examples here. And you can see how these work in action. So our first example, I'm going to give you an ordered pair of 1, 6. And the second pair, 7, 9. So on this one, we have 2 x's. We have x1 and x2. 1 and 7 are the 2 x coordinates. The 2 y coordinates are 6 and 9. So if we want to find the slope, we do y2 minus y1 over x2 minus x1. So here, y2 is 9 minus y1 is 6. And then for the denominator, we're subtracting the x coordinates. So we go x2, which is 7, y2, or x1 is 1. So then we can just subtract, and we get 3 over 7 minus 1 gives me 6. And then 3 6 can be reduced to 1 over 2. We reduce that by 3. So on this one, our slope is a positive 1/2. Now, you could always plot those points on a graph and count, but I do think the formula, once you get the hang of it, is much, much quicker. So we'll do a couple more examples. The next one, I'm actually going to throw in a negative. All right, so we have two ordered pairs. The x's are -5 and 4. The y coordinates are 2 and -7. So if we want to subtract, we always do y's first because the y's are the rise, because the y-axis is the one that goes up and down. So that talks about the y-axis is the rise. All right, so for the y's, the y2 is -7 minus 2. Now for the denominator, our x2 is a 4, but then we subtract -5. So on this one, the 4 came from x2, then it was a minus sign, so we brought that over, and then we bring down the -5. So we now can add those. -7 minus 2 becomes -9 over. Now when you have negative or 4 minus -5, that really means, remember, that's really 4 plus 5, so that turns into a +9. So here we have a -9 divided by a +9 to give us, we could simplify that just to a whole number, -1. And so what that would mean on a graph, from point to point, you go down 1 and over 1, because that's actually -1 over 1, but we can always write it as a whole number. So it would go down 1 and over 1 from point to point, and it would look like that on our graph. All right, I have two more examples with the slope formula, and then we'll talk about intercepts. All right, so on the slope formula, I have 3, 6, and 3, -10. Okay, so we are going to do y2 minus y1 on top, x2 minus x1 on bottom. So our x or our y coordinates are 6 and -10. So we're going to do -10 minus 6. On the denominator, our x coordinates are 3 and 3. So what happens when I take 3 minus 3? I get 0. And then on the top, I get -16. So if you actually type in -16 divided by 0 on a calculator, you get an error. You cannot divide by 0, so we actually write the word undefined. Except I got to learn how to spell it. Undefined. So I will tell you, when 0 is under the fraction, it is undefined. So that is something, when 0 is under, then that means the slope is undefined. That might be an easy way for you guys to remember that. Under, undefined, they kind of go together. But dividing by 0, you can't take 16 things and make 0 groups. You can't divide by 0. So this is an undefined slope. And then our last example is on the other side of it, -1, 5, and 2, 5. So on this one, your y coordinates are 5. So if you want to, on your slope, take y2 minus y1, your numerator is actually going to be 5 minus 5. Now for your denominator, you're doing x2 minus x1, which your x coordinates are 2 minus -1, which turns into 2 plus 1. So you're actually going to end up with 0 over 3. Now, 0 divided by anything is 0. So on this one, we would actually say the slope is 0. And if you want to actually write the word 0, I'm also okay with that. Either one of those would be acceptable. So if the y coordinates are the same, the slope is 0, because that means that there's no rise and run. So no rise just means it's a flat line, and flat lines have a 0 slope. So we will be doing more practice with slope, but make sure that you have all of those written down. it is review for middle school, so hopefully you guys are comfortable with that. But we actually need to move on to the last part of our lesson, X and Y intercepts. So an x-intercept is a point on a graph. It's actually a point where a line crosses the x-axis. And the same thing, the y-intercept is a point where a line crosses the y-axis. So if I were to draw a line, and I have my x-axis here and my y-axis here, if I were to just draw a random line through here, this point right here, where it crosses the x-axis, that would be the x-intercept. And the point right here where it touches the y-axis is what we would call the y-intercept. And so we will be doing some examples here, finding the x and the y-intercepts. And I really hope that you guys are able to do the live so you can actually see me do this instead. Oh, I've created the maximum number of boards. Great. Okay, so I am actually going to go back and erase a board that we don't need now. Oh, let's just delete that one. Okay, so if I give you an equation, all equations with an x and a y can be graphed as a line. All right, so if I want to find the x-intercept, I have to solve for x. If I just show you, if I have a point on the x-axis, you have an x-coordinate, the y is 0. So on the x-intercept, the y pretty much can just be ignored. So to find the x-intercept, I simply just write the equation without the y term. Because if the y is 0, then 5 times 0 would become 0. So on this one, if I want to find the x-intercept, I only need the part with the x and the constant. And then I just solve it. I divide by 9. So I get my x-intercept. This one would be a fraction. That would actually be really hard to graph. The x-intercept would be negative 10 over 9. Now, if you want to find a y-intercept has an x-coordinate of 0 and then a y coordinate. So whenever you are finding a y-intercept, just like the opposite, you only worry about, you kind of ignore the x. So we just solve the equation, 5y equals 10. So then we divide by 5. And so I would get my y-intercept. You see how I don't say y equals? I say the y-intercept is 2. So on this one, we would actually be able to graph this. And I'll say, let me erase this part because I can actually show you what it looks like. All right, so negative 10 over 9 is a little bit smaller than negative 1. All right, so 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So on this one, the x-intercept is negative 10 over 9, which is a little bit past negative 1. So we would actually make a point on the x-axis just a little bit past negative 1 because it's negative 1 and 1/9. Then the y-intercept is a positive 2, so we would actually go on the y-axis to positive 2, so that's up 2. And then to make the line, you would just connect the points. So we're not graphing today, we're just solving, but I wanted to show you guys where those come from. So I'm going to do one more example, so I'm going to delete this slide. And if you have an equation like this, x minus 3y equals 12. Okay, if I want to find the x-intercept, I only want to look at the variable x. So I'm actually going to, just for a second, we're not going to pay attention to this term. We're not going to pay attention to that. So that equation is left with x equals 12. So guess what? Your x-intercept is 12. Now on a graph, the x-coordinate would be, it would be like that. Now for the y, say, we got to go back to the original. I probably shouldn't have done that because it's not as easy to see. All right, so to find the y-axis or the y-intercept, again, we only worry about the y. So this x term, we can just kind of ignore. And we're going to solve this. Negative 3y equals 12. So we would divide it by negative 3, and we solve y equals 4. So that tells me that the y-intercept is equal to 4, negative 4, sorry. And on a graph, we would actually graph that point 0, negative 4. All right, so I'll do one more just to make sure that we have that. All right, my last example, I'm going to go with 7x plus 4y equals 28. So for the x, I only have to look at, I ignore the y. So I'm solving the equation 7x equals 28. And I divide by 7, I get x equals 4. So my x-intercept is equal to 4. Or the point 4, 0, because that's an x-coordinate. The y is 0 because we ignored it. Now for the y-intercept, we ignore the x. So we solve 4y equals 28. We divide by 4. That gives us 7. So that means that our y-intercept equals 7. So that means the y-coordinate would be 7. The x would be 0. So we'll do more with the intercepts. Today, I'm honestly just worried that you know how to solve those. It is okay to get a fraction. It's okay to get a whole number. That's totally dependent on the different types of equations. So I just want to let you know, if you have any questions, email me. I will be going live, so hopefully you guys can do some examples there. And I will see you all tomorrow. Have a great day.